Today, we're demystifying one of Java's most powerful ideas, abstraction. Let's dive right in.
So let me ask you a question. When you hop in your car, do you need to understand exactly how the engine works, every single moving part, just to get where you're going? Of course not, right? You just use the simple stuff, the steering wheel, the brakes, the accelerator. You're not thinking about pistons firing or fuel injection systems. You just press the gas and you trust the car will go. And that core idea, hiding the complexity, is exactly what we're talking about today.
And that's precisely what this explainer is all about. We're going to break down how Java uses this exact same principle, called abstraction, to help you build programs that are way cleaner, more flexible, and so much easier to maintain.
Okay, so let's pop the hood on this idea. What is abstraction, really?
At its heart, it's all about simplification. It's the practice of hiding all the complex, messy stuff behind the scenes and only showing the user the essential things they actually need to work with.
And this brings us right back to that car analogy. The steering wheel and pedals, that's the essential exposed interface. The engine mechanics, the transmission, that's the complex hidden stuff. Abstraction is that wall that separates the two.
All right, so that's the big picture idea. But what does this actually look like when you're writing Java code? Let's take a look at a blueprint.
So check this out. We've got an abstract class called animal. Now, notice two really important things here. The class itself is marked with the abstract keyword, and it has this method, sound, which is also abstract. And look, it has no body. It's just a declaration. But then, right below it, we've got a normal concrete method called sleep, which does have an implementation.
Let's break that down a bit more. Because animal is abstract, you can't just create a new animal object directly. It's just an idea, a template. That abstract sound method, think of it like a contract. It forces any class that wants to be an animal to provide its own version of a sound. And the sleep method, well, that's just the shared behavior that every subclass gets for free.
Now, let's see how we use this. We create a dog class, and it extends animal. By doing that, our dog class is agreeing to that contract. It's providing the missing piece of the puzzle, the specific implementation for the sound method, and in this case, a dog barks. And here, this is where the magic really happens. We're creating a dog object, but look, we're storing it in a variable of type animal. We're treating our specific dog like a general animal. So when we call mypet.sound, Java is smart enough to use the dog-specific bark method. But when we call mypet.sleep, it just uses the shared method from the animal class. We get to interact with the simple animal abstraction, not the nitty-gritty dog details.
Now I know what you might be thinking. This feels like a lot of extra steps, doesn't it? Which brings up a really good question.
Why not just stick the sound and sleep methods directly into the dog class and call it a day? Why bother creating this abstract animal blueprint at all?
Well, it all comes down to this one incredibly powerful idea. Abstraction separates what an object does from how it does it. The animal class defines what an animal can do, make a sound, and sleep. The dog class defines how a dog specifically accomplishes that. In our code, the what is the exposed part. The method names, sounding, and sleeping, the how. That specific line of code that prints dog barks is totally hidden away inside the dog class.
This separation gives us some huge advantages. It cuts down on complexity because we can think at a higher level. It stops us from duplicating code, like that sleep method. And best of all, it makes our code incredibly flexible. We can add a cat class or a cow class later, and any code that works with a general animal type doesn't need to change one bit. We call this loosely coupled code, and it's the key to building big systems you can actually maintain.
Now, just like driving a car, there are some rules of the road you need to know to use abstraction the right way.
And here's the #1 mistake pretty much everyone makes at first. You cannot, I repeat, cannot create an instance of an abstract class directly. This line of code will cause a compiler error. And why? Because an abstract class is an incomplete idea. It's a blueprint, not a finished building. You can't just make a generic animal. You have to make a specific kind, like a dog.
People also get abstraction confused with another concept, encapsulation. Here's the simple difference. Abstraction is about hiding complexity. Encapsulation is about hiding data. Think of it this way. Abstraction is the car's dashboard. It gives you simple controls. Encapsulation is the locked engine bay. It protects the private data and mechanics inside from being messed with.
Okay, we've covered the theory, we've looked at the code, now it's time for you to put it into practice.
I've got a little challenge for you. Pause this explainer for a moment and try to create your own cat class. Make sure it extends animal and then give it its own meow sound. Go ahead, give it a shot.
So let's wrap up with the key takeaways. Remember, Abstraction is your tool for creating a common blueprint for related classes. It forces them to follow a contract, guaranteeing certain behaviors. And ultimately, it lets you write cleaner, way more flexible code by focusing on the what, not the how.
But believe it or not, abstract classes are only half the story. If you think this is powerful, just wait until you see what you can do with interfaces. They take this whole concept of abstraction to another level entirely. And that's exactly what we'll be breaking down in the next explainer. See you then!